In this video, we're gonna talk about differential equation. The differential equation that we're gonna study is gonna turn out to be just the first order one. Okay, so let's begin by introducing what the meaning of the differential equation. A differential equation is an equation that involves the derivative or differential of an unknown function. For example, you have dy dx equal to 2x minus 4. And for this guy, you see that the thing that you like to solve for an unknown function turned out to be y. So this y is an unknown function. In the second equation, you have the second derivative of y with respect to x plus dy dx to the third equal to e to the x. So you like to know what is the function y that will satisfy this relation or this equation, okay? So what does it mean to solve this differential equation? We like to recover the function y that has derivative equal to 2x minus 4. So if I begin with dy dx equal to 2x minus 4, okay, so I'm gonna write it here. So you would get dy equal to 2x minus 4 dx. So you write this one in a differential form. So you have dy dx equal to 2x minus 4 dx, and you would just integrate both sides. So in order to recover y, so you like to get rid of the differential operator here. However, the way to get rid of the differential operator is going to be you need to integrate both sides. Okay, so you integrate dy, so you would get just y, and you integrate 2x minus 4, so this would give you x squared minus 4x and plus a constant c. So this one will be your solution in this case. Okay, so you have y equal to x squared minus 4x plus c, and this one will be your solution. And you see that c is just any constant. And you see that this guy gonna be, c can be vary from c equal to 0, c equal to -1, c equal to √2. So c can be any constant. And you see that it's not going to be a unique solution. It's not going to be only one solution. It's turned out to be infinitely many solutions. And this form will be given in terms of c. And the solution of this form is called the general solution. Okay, so this one is going to be the general solution of the first differential equation, dy dx equal to 2x minus 4. And you see that c can be varied, so it's going to turn out to be infinitely many solutions. Okay, so it's going to be infinitely many solutions. Okay. However, if we specify the value of y at a certain point x, okay, so if you don't want to have the general solution, you can do this guy by specify the value of y at some value of x. So for example, you're gonna specify y2 equal to -1. So if you say that you don't want to have general solution, you want the solution that satisfies y2 equal to -1. This guy has a special name. So this guy is called initial condition. Okay, so this guy has a special name called initial condition, and you can use this condition in order to find the constant c. So you see that you can plug in x equal to 2. So you plug in x equal to 2 places here. So it's going to be 2 and it's going to be 2. So you get 2 squared minus 4 times 2 plus c equal to 1. Sorry, equal to -1. So this guy is going to be -1. And then this allows you to solve for c. So you would get c equal to 3. So after you know C equal to 3, so you're gonna plug in C into the general solution to obtain the thing that called particular solution. So this one is called particular solution that satisfies the initial condition y2 equal to -1. So you're gonna have two kind of solution. The first one is called general solution that turn out to be very involving the constant C. Another one turn out to be the particular solution that is gonna turn out to be satisfy the given condition called the initial condition. Okay, so this is the first slide for the meaning and the kinds of solution of differential equation. Let's do one example. We like to recover the function fx that satisfies f prime x equal to 3x squared plus 4x minus 1 and f2 equal to 9. And you see a special terminology here that is called initial value problem. What is the meaning of the initial value problem? So for this initial value problem, it means you have differential equation together with initial condition. Okay, so you get the initial value problem. Okay, so let's solve this one. So you have f prime x equal to 3x squared plus 4x minus 1. And you may have learned this one in Calc 1 that if you know f prime x, in order to recover fx is going to turn out to be, you can do this one by just integrate. So you're going to just integrate f prime x dx, you're going to get fx. So you have integrate 3x squared plus 4x minus 1 dx, and you integrate 3x squared plus 4x minus 1, so you would get x cubed plus 2x squared minus x plus c. Okay, so it's going to be integrate 4x, you get 2x squared minus 1, so it's going to be integrate 1, you get x and you plus c. And here you get the thing that called general solution. Okay, so this guy is called general solution. And you're gonna use the initial condition f2 equal to 9. Okay, so we use f2 equal to 9 to find the constant c. So you're gonna plug in f2, so it's gonna be 2 to the third minus 2 times 2 square, okay, minus x, okay, plus c, okay. So this one, okay, so it's gonna be 2 minus x, okay. And you're gonna have f2 equal to 9. Okay, so it's gonna be 2 to the third, okay, plus 2 times 2 square. Okay, so you get 2 times 2 square minus x plus c. Okay, so it's gonna turn out to be this one. And I make mistake, it's gonna be plus here, right? So this one will be 9 equal to 16 minus 2. So it's going to be 14 plus c. So this allowed me to get c equal to -5. Okay, so this allowed me to get c equal to -5. And you're gonna plug into the general solution. So this would give you fx equal to x cubed plus 2x squared minus x minus 5 is the general solution. Sorry, is a particular solution, or is the particular solution. Okay, so we be able to obtain the solution that satisfy the initial condition F2 equal to 9. Okay, and it's going to be just you plug in to obtain C, and this one is your C. Okay. Okay, so this one is how we solve the initial value problem in this example. The next one, we consider the differential equation y squared times y prime equal to 3x squared. We like to show first that yx equal to 3x cubed plus c to the 1/3 is the solution for this given differential equation. Okay, so first of all, you like to plug in y squared into the differential equation, and you like to plug in y prime. So you have y prime equal to, so you differentiate this one, so it's going to be 1/3, and you have 3x cubed plus c to the negative 2/3 times, so it's going to be 9x squared. So you would get 3x squared times 3x cubed plus c to the negative 2/3. Okay, so this one will be your y prime. And then you have y squared times y prime. So y squared times y prime is 3x cubed plus c to the 2/3 times y prime. So it's going to be 3x squared times 3x cubed plus c to the negative 2/3. So for this one, okay, so this one is going to be my green guy, y prime. Okay, and you see that you have to the 2/3 and to the negative 2/3 will cancel each other nicely. So you would get just 3x squared. Okay, so this one is the way that we're going to show that you have y squared times y prime turn out to be equal to what? Turn out to be equal to 3x squared. And this one is your A. Okay. For your B, you're gonna find the particular solution satisfying y1 equal to -1. So you're gonna have y1 equal to -1. So it's y1. So it's gonna be 3 times 1 to the 3rd plus c to the 1/3 like this. And you're gonna have to get rid of to the 1/3. So you're gonna raise everything to the 3rd power. So you get -1 to the 3rd, and you have 3 plus c. Okay, so this guy is -1, and you would get c equal to -4. Okay, so we have the particular solution y equal to 3x to the 3rd minus 4 to the 1/3 is the particular solution that you are looking for. Okay, so this one will be your particular solution in this case. So you see that this one, we don't know how to solve this differential equation yet, but the thing that you may notice will be, you see that it looks like you have only y on one side and only x on the other side. And if you write this differential equation, so it's going to be y squared dy dx equal to 3x squared. And you see also that this guy can be written as y squared dy equal to 3x squared dx. So you see that we can separate the variable y on one side. So you see that you have y only on one side and x only on the other side. So this is a special differential equation that kind of important and allow us to solve the differential equation nicely. So we consider the first order differential equation of the form. The word first order here means that the order of derivative is only the first derivative. Okay, so it's going to be involving first derivative. First derivative is mean you differentiate only one time. Okay, so first order means first derivative. So it's going to be equation that involving only first derivative, and you have dy dx equal to fx times gy, and you see that you can separate the variable, so you allow to have y together with gy and x together with fx. So you see that you can move the yellow guy to join on the same side. So you get 1 over gy dy, and you have fx dx. So it's going to be like this, and you see that it's going to turn out to be separate y on one side and the fx on the other side. And this will allow us to solve this differential equation by integration. Okay, so in order to recover the function g and function f, we will be able to just integrate both sides. Okay, so for this one, like we have done earlier, so we know that it's y squared dy equal to 3x squared dx. Okay, so this is what we have written so far. And you see that this guy is the yellow function, and this guy is the pink function. Okay, and you're gonna just integrate both sides. So you integrate y squared dy, so you get y cubed over 3 plus c1, and you have integrate 3x squared dx, so this guy will be just x to the third plus c2. Can be plus by the same c. If you not using C1 and C2, you have C and C like this, you're gonna cancel them out. Okay, so you have nothing left. So in this case, the thing that we're gonna do is gonna be, this one is one integral, you're gonna plus C1, and this one is another integral, you're gonna plus C2 instead. So you not be able to cancel them out. The thing that you can best do is going to be just, you can combine the term. So you get y cubed over 3 equal to x to the third plus c2 minus c1. Okay, and some of you may just, hey, can we just multiply by 3 also? Yeah, okay, you can. So you get 3x to the third, 3 and 3 like this. And you see that it's kind of not nice in order to write the solution. So you're gonna just change this 3c1 minus 3c2 minus 3c1 into just constant c. So this one is gonna be like a long constant. Okay, so it's long constant, it's not quite nice. So we're gonna just combine them into only one constant, and you're gonna be able to write the solution nicer. So in this case, you would have, okay, so you would have y cubed equal to 3x to the third plus c, and this will be your y equal to, okay, so this one will allow you to have y equal to 3x to the third plus c to the 1/3. Okay, so this one is the one given in the previous example, and this is the way to obtain y. Okay, so this one is called the general solution. Okay, so this one is called the general solution, and it's given by y equal to 3x squared, 3x to the third plus c to the 1/3. Okay, so for this one, you see that you don't need to plus both sides. So you basically just plus one side of the equation, that's fine, okay, for this constant, okay? So you don't need to plus both sides for that guy. Let's do one more for the equation. Y prime equal to e to the 4y times x cubed minus e to the 4y. So for this guy, you see that this y will be dy dx. So this one, this will be dy dx, right? So it's gonna turn out to be e to the 4y x cubed minus 1, and you're gonna multiply with dx. Okay, so you would get e to the negative 4y dy equal to x cubed minus 1 dx. And you can integrate both sides like this. So you integrate e to the negative 4y, so you get e to the negative 4y over negative 4 equal to integrate x cubed. So it's going to be x to the 4th over 4 minus x. And don't forget to plus c, okay? So this one will be just plus 4y plus c. And then you see that you get e to the negative 4y equal to, you can multiply the whole thing by 4. So it's going to be negative x to the 4th plus 4x minus 4c, okay? So this one will be your general solution. And this would allow you to have the solution in this form. And some of you may ask me that, can we solve for y? Okay, so this one I have to say first that this one is acceptable for final answer. But sometime you'll be able to solve for y, you can. So if you like to solve for y, you can just take log both sides. Okay, so you take log, so it's going to be log e to the negative 4y equal to, let me erase this one a little bit. So you just take log e to the negative 4y equal to log negative x to the 4th plus 4x minus 4c, okay? And then this guy will be negative 4y, okay? So you have y equal to negative 1/4 log negative x to the 4th plus 4x minus 4c. Okay, so this one will be your y, okay, that will satisfy this differential equation. Okay. Another guy will be, you have y prime equal to 2 minus y, and you have y0 equal to 4. And the question asks you to solve for particular solution. So particular solution, you first will need the general solution. So you have dy dx equal to 2 minus y. Okay, so you have dy dx equal to 2 minus y, and this will be 1 over 2 minus y dy equal to dx. Okay, and you integrate both sides. Okay, you integrate 2 minus y, you would let u to be 2 minus y, and you have du equal to negative dy. Okay, and you're gonna have integrate 1 over u, and you have minus y, so it's going to be minus dy, minus du. So you get negative log absolute u. Okay, and so this guy will be negative log 2 minus y. Okay, so it's going to be negative log 2 minus y. And this guy, you integrate dx. So you integrate dx, so it's going to be x plus c. Okay, so you integrate dx, so it's going to be x plus c. And so you get this differential equation. Okay, so this one is called what? This one is called general solution. Yeah. So this guy is going to be just general solution. And we're gonna use y0 equal to 4 in order to solve this one. Okay, so since y0 equal to 4, so you get negative log 2 minus 4 equal to x equal to 0 plus c, and this will give you c equal to negative log 2. Okay, so you have c equal to negative log 2 in this case, and this will allow you to just have the particular solution. So the particular solution in terms of negative absolute like this equal to what? Equal to x minus log 2. Okay, so this one will be just the particular solution that you have find. So it's going to be this one, okay? And this one will be your final answer, okay? So you don't need to solve for y if it's turned out to be complicated like this one, okay? Like I said, it's not necessary. So you'll be able to just give me the solution in the form here. Sometimes this guy is called implicitly form, implicit. Okay, so it's going to be implicit. And if you be able to solve for y like this, it's called explicit. So they are opposite of each other. So let's continue. So you like to find the particular solution for y prime equal to x squared minus 2 y squared over x times y squared plus 3. So this one, if I highlight some color, it would be clearer. So you see that y prime turned out to be dy dx. And you have the term x squared minus 2. So I'm going to have x squared minus 2 over x times y squared over y squared plus 3. So this guy will be the yellow y, okay? And you have the pink one, which is x. So you see that you're gonna have to separate the pink one together with the pink one and the yellow one to be with the yellow one, and make sure that you have dy and dx on the numerator level. You cannot have 1 over dx or you cannot have 1 over dy in order to be able to integrate them. So for this one, it can be written as y squared plus 3 over y squared dy equal to x squared minus 2 over x dx. So this one, you see that it's gonna turn out to be the pink one and the yellow one. Okay, so this one is the pink one and the yellow one. And you can integrate, okay? So you can just integrate both sides. So you can just integrate this guy both sides. It's turned out to be integrate of 1 plus 3 over y squared dy equal to integrate of x minus 2 over x dx. Okay? And you just integrate 1 plus 3 over y, 1 plus 3 over y squared. So this guy will be 1 minus 3 over y. And you integrate x, you get x squared over 2. Integrate 2 over x is going to be 2 log absolute x plus c. Okay, so this one will be your final answer for general solution. However, the question gives you y1 equal to 2. Okay, so this one is going to be the initial condition that allow us to solve for c. Okay, so we use this guy and we would solve for c. So you get 1 minus 3 over 2 equal to 1 over 2, 1 square over 2 minus 2 log 1, absolute 1 plus c. Okay, so this one will give you 0. Okay, so it's gonna be log 1 equal to 0, and this one will be c equal to negative 1 totally. Okay, so you solve for c and you get c equal to negative 1, 1 minus 2. So you have c equal to negative 1, and you're gonna just answer 1 minus 3 over y equal to x squared over 2 minus 2 log absolute x minus 1 is the particular solution. Okay, so this one will be your final answer. Okay, the next one, you like to find the particular solution for this differential equation, and you have y times y plus x squared y dy equal to 2x dx. Okay, and you like to solve for y0 equal to 4, and you use y0 equal to 4 for the initial condition, and you're gonna solve for c. I'm gonna leave this one for you to do on your own first, and I'm gonna give you the solution at the recitation. Okay. The next one, you have drdq equal to this term, okay, equal to 50 minus 4q e to the negative r over 5. So you see that this one is separable. So you have the yellow guy and you have the pink guy, okay? And this can be written as e to the r over 5 dr equal to 50 minus 4q dq. And you're gonna integrate both sides. Okay, so you integrate e to the r over 5, so it's going to be e to the r over 5, 1/5 equal to 50 q minus q square, not q square, 2q square plus c. Okay, so this will allow you to have 5 e to the r over 5 equal to 50 q minus 2q square plus c. Okay, so this one will be your final answer. Okay, so this one is find the demand equation for the monopolist products. Okay, so that will be the demand equation that you have by solving this differential equation. Okay. Okay, the next one, if the amount of sale Y is related to the price per unit P by this form, we like to find the amount of sale if the price is 13 baht, given that the amount of sale is 5,000 units when the price is 1 baht per unit. So for this one, the question gives you y1 equal to 5,000. Okay, so this is what you should think about. And the question asks you to find y13 equal to what? Okay, so you need y13 equal to what? Okay, so the amount of sale at 13 baht. So first of all, you're gonna solve for y. Okay, so you're gonna solve for y, and you see that this guy is 1 over y dy equal to negative 1 over 2p plus 3 dp. Okay, so this one will be just this differential equation, and it's gonna ask you to integrate. Okay, I leave you with this one first to do this one on your own, and you're gonna find C by using y1 equal to 5,000, and then you plug in p equals to 13 for me in order to obtain y13. Okay, so I leave you this one for doing on your own first, and then I'm gonna give you the solution at the recitation. Okay, so I'm gonna stop here for this first part. So this first part consists of the way to solve differential equation involving the technique called the method of separation of variable. Okay, so the second one is gonna be the linear equation, and the third one will turn out to be the application.